Hello and welcome back to Math with Mrs. Becker. Today we are looking at college algebra and chapter 2, section 3. We will be dividing polynomials using a process called long division, synthetic division, and then talking about something that is called the remainder theorem. So first let's start off by using long division. If I am dividing 6x to the power of 3 minus 19x squared plus 16x minus 4 by x minus 2. The x minus 2 goes outside of the division symbol. Now, when you write your polynomial underneath, you want to make sure that it is in standard form and you are not skipping any x values. So this is 3x's, 2x's, 1x's, no x's. So we're good to go. 6x cubed minus 19x squared plus 16x minus 4. Now your goal here is to always make the first term on the outside become the first term on the inside. So I need x to become 6x cubed. So you have to ask yourself, okay, what is it missing? It needs a 6 and it needs 2 additional x's. 6x squared times x is 6x cubed. 6x squared times negative 2 is negative 12x squared. Okay, so notice what I did here. I made the first term on the outside match the first term on the inside. Whatever it was missing went on the top. Then I took the 6x squared times x. These two terms should match. Then the 6x squared also has to be multiplied by the negative 2. We have to combine those. Our goal is to always cancel the first term. Well, in order to cancel the first term, I need to change the signs of the whole second row. That way, this becomes a negative. Positive 6x cubed, negative 6x cubed cancels. If I combine these, negative 19x cubed, negative 19x squared plus 12x squared is negative 7x squared. I have 2 terms on the outside, so you always need 2 terms that you're looking at. So I drop down the 16x. Now we start again. The first term on the outside needs to become the first term on the inside, which is now negative 7x squared. To turn an x into negative 7x squared, you need a negative 7 and 1 more x. Negative 7x times x is negative 7x squared. Negative 7x times negative 2 is positive 14x. Now, in order to cancel the first term, you change the signs of the whole second row. That becomes a positive, that becomes a negative. This cancels. 16x minus 14x is 2x. Carry down the next term. To turn an x into a 2x, you need a 2. 2 times x is 2x. 2 times negative 2 is negative 4. In order to cancel the first terms, you change the signs in the whole second row. Positive 2x, negative 2x, negative 4, positive 4. There's nothing left to drop down, so you do not have a remainder. Your solution is 6x squared minus 7x plus 2. Let's look at another one. Whatever you are dividing by, that's what goes on the outside. Whatever you put on the inside, make sure that it's in standard form and you do not skip any x values. 2x's, 1x's, no x's. So it's x squared plus 3x plus 5. To turn the outside term into the inside, to change x into x squared, you need an x. X times x is x squared. X times 1 is 1x. To cancel the first term, I change everything in the second row, all of the signs. Positive x squared, negative x squared cancels. 3x minus 1x is 2x. Carry down the positive 5. Start again. To change x into 2x, I need a 2. 2 times x is 2x. 2 times 1 is 2. Change the signs of the second row. Positive 2x, negative 2x cancels. Positive 5 minus 2 is 3. There's nothing left to bring down. I cannot change a letter into a number. So this is your remainder. The way that you write your remainder, this is positive, so I put plus. Whatever this value is, that goes above your divisor. So 3 goes above x plus 1. So your answer is x plus 2 plus 3 over x plus 1. Okay, let's look at another one. Number 3, whatever you're dividing by, that's what goes on the outside. Now here I have 3 x's and no x's. That doesn't work. I need to go 8x cubed, no x squareds, no x's, minus 1. So it's 3 x's, 2 x's, 1 x's, no x's. Step 1, I need 2x to become 8x cubed. To turn a 2 into an 8, you need a 4. I have 1x, I need 3, so I need 2 more. 4 times 2 is 8. 2 x's and 1 more gives me 3. Now take 4x squared times negative 1. That's negative 4x squared. In order to cancel the first term, change the signs of all of the second row. This cancels. 0x squared plus 4x squared is 4x squared. Carry down the next term, even though it's a 0. Start again. 2x needs to become 4x squared. To turn a 2 into a 4, you need a 2. This has 1x, I need 2, so I need 1 more x. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. In order to cancel the first term,
Can I have a custodian to the loading dock for a delivery, please?
Sorry.
Custodian to the loading dock for a delivery. Thank you.
Okay, what I need to do here is cancel the first term. So I change the whole second row. I change this to a negative. This was a negative, so now it's a positive. Now the first term cancels. 0x plus 2x is a 2x. Carry down the next term, which is a negative 1. To turn 2x into 2x, if they already match, you put a 1. 1 times 2x is 2x. 1 times negative 1 is negative 1. To cancel the first term, you change the sign. Negative, positive, cancels, cancels. There's nothing left to bring down, so you do not have a remainder. So your answer is 4x squared plus 2x plus 1. One more example for long division. Okay, this time, check this out. What we're dividing by is x squared plus 2x minus 3. We have 3 terms on the outside, okay? We're like doing the varsity style for long division. Now, this is a hot mess. You need to make sure that this is in standard form. The highest exponent is 4. So 2x to the power of 4 comes first, followed by 4x cubed, then a negative 5x squared, plus 3x minus 2. 4x is 3x is 2x is 1x, no x's. Now, even though there are 3 terms on the outside, the process is the same. I need to make the first term on the outside become the first term on the inside. So I need a 2. This has 2 x's. I need it to have 4, so I need 2 more. 2x squared times x squared is 2x to the power of 4. Now your 2x squared comes to the 2x. 2 times 2 is 4. 2 x's and 1x makes x cubed. Now it comes to the negative 3. 2x squared times negative 3 is negative 6x squared. In order to cancel the first term, I need to go to the whole second row and change the signs. Negative, negative, positive. That cancels, so does that. So I have negative 5x squared plus 6x squared, that's 1x squared. Carry down the 3x, carry down the negative 2. I carry down 2 terms this time because the outside has 3. I need to be looking at 3 terms. Start again. The first term on the outside needs to become the first term on the inside. If they match, it's a 1. 1 times x squared is x squared. 1 times 2x is 2x. 1 times negative 3 is negative 3. In order to cancel that first term, you change the signs of everything in the second row. Cancels. 3x minus 2x is 1x. Negative 2 plus 3 is 1. I cannot change x squareds into x's. So it's possible to have a remainder that has more than 1 term. And it's possible to have variables in your remainder. The first value is positive, so it's plus x plus 1 over your divisor, x squared plus 2x minus 3. So our solution actually looks like this, 2x squared plus 1 plus the fraction x plus 1 over x squared plus 2x minus 3. And that, my friends, is long division. Let's go ahead and turn the page. Okay, there is a shortcut. It is called synthetic division, but it only works when the divisor is in this form, x minus k. Okay, so what you have to do is realize that the formula has a negative. So if you have two values either being added or subtracted, and that's your divisor, it will be the opposite of what it appears because the formula is a negative. That's what you would use. Then what you can do is just use the coefficients. Let's try a couple. So if I am dividing by x plus 3, the formula is x minus what? Well, I would be minusing a negative 3. That's how I would get this to be a plus 3. So the negative 3 goes in a box. Now, again, we have to make sure we don't skip any x values. The highest exponent is a 4. The coefficient in front of a 4 is 1. I do not have an x cubed, so that's a 0. The coefficient in front of x squared is negative 10. The coefficient in front of x is a negative 2. My constant at the end is a 4, so this is 4x's, 3x's, 2x's, 1x's, no x's. For synthetic division, you always carry down the first term. Whatever this value is, it carries down. So in our case, it's a 1. Now you take the number on the bottom and you multiply it by the number in the box. 1 times negative 3 is negative 3. Now you add these. 0 plus negative 3 is negative 3. Now we multiply. Negative 3 times negative 3 is positive 9. Add. Negative 10 plus 9 is negative 1. Multiply. Negative 1 times negative 3 is positive 3. Add. Negative 2 plus 3 is 1. Multiply. 1 times negative 3 is negative 3. Add. 4 plus negative 3 is 1. Now when you're done, when you've gone through all of the values, the last number, that is your remainder. Next to your remainder is your constant. Next to that is x, then it would be x squared, then it would be x cubed. So my final answer here would be 1x cubed minus 3x squared minus 1x plus 1. My remainder is a 1. It's positive, so it's plus 1 over. Our divisor was x plus 3. That is synthetic division. Look how much quicker that is. But again, long division works 100% of the time. So it's important to understand long division, but synthetic division is pretty darn quick if your divisor is in that form. Let's look at another one. My divisor is x plus 3. So that means a negative 3 would go in the box. 3x's, 2x's, 1x's, no x's. So I do not have to add any zeros. 5 is the coefficient in front of x cubed. 18 is in front of x squared. 7 is in front of x, negative 6. You always bring down the first number. So in this case, my first number is a 5. 5 times negative 3 is negative 15. You add these. 18 plus a negative 15 is 3. Multiply. 3 times negative 3 is negative 9. Add. 7 plus a negative 9 is negative 2. Multiply. Negative 2 times negative 3 is a positive 6. Add. Negative 6 plus positive 6 is 0. This is always the remainder. If it's a 0, it means you don't have a remainder. This is a number. This is x. This is x squared. So my answer would be positive 5x squared plus 3x minus 2. There is no remainder. Okay. Sometimes they're going to have a fraction. It's okay. This is still in the right format where you can do synthetic division. So x minus 3 halves would put a positive 3 halves in the box. 3x's, 2x's, no x's. So I need to be careful and make sure I add in a 0 for x. So it's 3, negative 4, 0, 5. 3x's, 2x's, 1x, no x's. Bring down the first term, which is a 3. Now I'm going to keep a separate sheet of paper here to work on our fractions. If I multiply 3 times 3 halves, top times top, bottom times bottom, so that's 9 halves. Now if I am adding negative 4 over 1 plus 9 halves. I need to have a common denominator. So I need to make this negative 8 halves plus 9 halves. My common denominator is a 2. Negative 8 plus 9 is 1. So this is 1 half. If I'm multiplying, I am taking 1 half times 3 halves. Top times top, bottom times bottom. This would be 3/4. 0 plus 3/4 is 3/4. Multiply. So I have to take 3/4 times 3 halves. Top times top, bottom times bottom. 3 times 3 is 9. 4 times 2 is 8. So this is 9/8. If I am adding, if I have 5 plus 9/8, this is like 5 over 1. I need a common denominator of 8, making this 40 over 8 plus 9 over 8. So my fraction is 49/8. Kind of wild, but we've got this. The last value, that is a remainder. This is a number, this is x squared. So I would have 3x squared plus 1/2 x plus 3/4. Now my remainder, I am going to go ahead and just let you go 49 over 8 over x minus 3 halves. I know typically you do not have one fraction over the other, but in the case of the remainder, don't worry about it. Our remainder is 49 over 8. That goes over what we were dividing by, which was also a fraction. Okay, the remainder that you obtain in synthetic division, it has an important interpretation, okay, as described in something called the remainder theorem. The remainder theorem tells you that synthetic division can be used to evaluate a polynomial. Okay, so check this out. If they want you to evaluate this function for x equals -2, what we typically do is you go ahead and you fill a -2 in for the polynomial, right? That's what evaluate means. So if I go 3 times -2 to the power of 3 plus 8 times -2 squared plus 5 times -2 minus 7, I get -9, okay? Sorry, I gotta slide this up a little bit. Okay, so when we evaluate, we get -9. Check this out. If I do synthetic division where I put this value in the box, 3x's, 2x's, 1x's, no x's. 3, 8, 5, -7. Bring down the 3. 3 times -2 is -6. 8 plus -6 is 2. 2 times -2 is -4. 5 plus -4 is 1. 1 times -2 is -2. -7 plus -2 is 9. The remainder, when you do synthetic division, is the same as evaluating the function for the number that's in the box. So in order to evaluate for -2, you could either go and fill -2 in for the x's, or you can do synthetic division, and whatever the remainder is, that's what you would get if you filled it in. Super cool. Okay, let's do one more just to make sure that that makes sense. Okay, I'm gonna grab another piece of paper here just to make sure I have room. Okay, so if I want to evaluate for 3, 3 goes in the box. 6x's, 4x's, 2x's, no x's. Okay, I need to add in some zeros. Okay, you have to be really careful. Anytime you're doing synthetic division, you cannot skip any x values. So 2x to the power of 6, I don't have any x to the power of 5s. 3x to the power of 4, I don't have any x cubes. -1x squared, I don't have any x's, 3. So 6x's, 5x's, 4x's, 3x's, 2x's, 1x's, no x's. Carry down the first term. 2 times 3 is 6. 0 plus 6 is 6. 6 times 3 is 18. 18 plus 3 is 21. 21 times 3 is 63. 63 plus 0 is 63. 63 times 3 is 189. 189 plus a -1 is 188. 188 times 3 is 564. 0 plus 564 is 564. 564 times 3 is 1,692. If I add that with 3, I would have 1,695. Now to check that solution, let's go ahead and take our original 2 times, replace the x's with a 3. 3 times 3 to the power of 4 minus 3 squared plus 3. If I fill this in, I should get 1,695. If I don't, I'm starting this video over, darn it. To the power of 4 minus 3 squared plus 3. 1695, it checks. We get to call it a day. Hope you guys had a great time. Talk to you soon.